NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we learn how to convert compound radicals like the square root of a plus or minus the square root of b into a sum or a difference of simple radicals. We'll also prove the formula in practice with clear examples. The target expression is the square root of a plus or minus the square root of b, where a and b are positive. Our goal is a clean, simple form. Here is the main theorem. Define c to be the square root of a squared minus b. Then the square root of a plus the square root of b equals the square root of open parenthesis a plus c close parenthesis over 2 plus the square root of open parenthesis a minus c close parenthesis over 2. For the minus case, we simply change the middle sign to a minus. Proof sketch for the plus case. Assume the square root of a plus the square root of b equals the square root of x plus the square root of y, with x at least y, and both non-negative. When we square both sides carefully, we can match the rational parts and the radical parts. Next, introduce c equals the square root of a squared minus b. Substituting a equals x plus y and b equals 4xy, we get c squared equals x minus y squared. Since x is at least y, c equals x minus y. Solve the simple system x plus y equals a and x minus y equals c. We obtain x equals a plus c over 2 and y equals a minus c over 2. Plugging back gives the formula for the plus case. The minus case is identical with a minus sign in the middle. Example 1. Let a equal 5 and b equal 24. Then c equals the square root of a squared minus b, which is the square root of 1, so c equals 1. Substituting into the formulas, we get the square root of 5 plus the square root of 24 equals the square root of 3 plus the square root of 2, and the square root of 5 minus the square root of 24 equals the square root of 3 minus the square root of 2. We can check the plus case by squaring. Example 2. Take a equals 7 and b equal 40. Then c equals the square root of 49 minus 40, which is 3. Therefore, the square root of 7 plus the square root of 40 equals the square root of 5 plus the square root of 2, and the minus version equals the square root of 5 minus the square root of 2. Again, squaring the sum confirms the result. In this lesson, we will simplify nested radicals using a clean, two-parameter method. We will follow the exact step order shown on the worksheet. Example. Problem statement. The square root of, open parenthesis, 2 plus the square root of 3, close parenthesis. Step 1. Define capital A equals 2 and capital B equals 3. Compute capital C equals the square root of a squared minus b. That is the square root of 4 minus 3, which equals 1. Step 2. Use the rule for the square root of a plus the square root of b inside one radical. The rule says the square root of a plus the square root of b equals the square root of, open parenthesis, a plus c, over 2 close parenthesis plus the square root of, open parenthesis, a minus c, over 2 close parenthesis. Step 3. Substitute a equals 2, b equals 3, and c equals 1 to finish. Second example. Problem statement. The square root of 7 minus 4 times the square root of 3. Step 0. Rewrite the inside as the square root of 7 minus the square root of 48. Step 1. Define capital A equals 7 and capital B equals 48. Compute capital C equals the square root of a squared minus b. That is the square root of 49 minus 48, which equals 1. Step 2. Use the rule for the square root of a minus the square root of b inside one radical. The rule says the square root of a minus the square root of b equals the square root of, open parenthesis, a plus c, over 2 close parenthesis, minus the square root of, open parenthesis, a minus c, over 2 close parenthesis. Step 3. Substitute the values and simplify to 2 minus the square root of 3. Final answers. First, the square root of 2 plus the square root of 3 equals the square root of 3, has plus the square root of 1/2. Second, the square root of 7 minus 4 times the square root of 3 equals 2 minus the square root of 3. Example. We will simplify the expression square root of 4 plus square root 7 minus square root of 4 minus square root 7 minus square root 2. Then we will use the standard nested radical decomposition rule step by step. Here is the key identity. For any non-negative numbers, a and b, where a squared is greater than b, define c equals the square root of a squared minus b. Then, the square root of a plus square root b equals square root of open parenthesis a plus c over 2 close parenthesis plus square root of open parenthesis a minus c over 2 close parenthesis. And with a minus sign between, you get the companion formula. In our problem, a equals 4, and b equals 7. Compute c squared equals 4 squared minus 7, which is 16 minus 7 equals 9. Since c is positive, c equals 3. Now, apply the rule to the plus case. Square root of 4 plus square root 7 equals square root of open parenthesis 4 plus 3 over 2 close parenthesis plus square root of open parenthesis 4 minus 3 over 2 close parenthesis. This becomes square root 7 over 2 plus square root 1 over 2, which equals square root 14 over 2 plus square root 2 over 2. Do the same for the minus case. Square root of 4 minus square root 7 equals square root of open parenthesis 4 plus 3 over 2 close parenthesis minus square root of open parenthesis 4 minus 3 over 2 close parenthesis. That becomes square root 7 over 2 minus square root 1 over 2, which is square root 14 over 2 minus square root 2 over 2. Now substitute both results into the original expression. We have open parenthesis square root 14 over 2 plus square root 2 over 2 close parenthesis minus open parenthesis square root 14 over 2 minus square root 2 over 2 close parenthesis minus square root 2. Distribute the minus sign and combine like terms. The square root 14 terms cancel. The remaining is a half square root 2 plus a half square root 2 minus 1 square root 2, which equals 0. Recap. In this lesson, we will master an intuitive algorithm for simplifying radicals of the form square root of a plus b times square root of c. We'll solve the classic example square root of 24 plus 6 square root 7, verify it, and then try 2 more examples. Here is the key visual idea. When we can rewrite the inside as a equals m plus n, and b times square root of c equals 2 times square root of n, then square root of a plus b square root c collapses beautifully to square root m plus square root n. We will use this by hunting for 2 numbers whose product is mn and whose sum is a. Example. Let's simplify square root of 24 plus 6 square root 7. Step 1. Reshape the mixed radical. So the coefficient 6 becomes the 2 from our pattern. We write 6 as 2 times 3, and then absorb the 3 into the radical as root 3 squared. This turns 6 root 7 into 2 times root of 63. Step 2. Assume the expression equals square root m plus square root n. Squaring both sides gives m plus n equals 24, and mn equals 63. Now we search for 2 integers with product 63 and sum 24. The winning pair is 3 and 21. Therefore, m equals 21 and n equals 3. So square root of 24 plus 6 root 7 simplifies to square root 21 plus square root 3. Quick verification. Square the answer. Open parenthesis root 21 plus root 3 close parenthesis squared equals 21 plus 3 plus 2 root of 63, which is 24 plus 2 root 63. That matches the reshaped inside. So our simplification is confirmed. Summary of the pattern we used. If you can rewrite as m plus n plus 2 root m n under a square root, it becomes root m plus root n. The whole game is to make the coefficient equal to 2 and then find the matching sum and product. Example. Simplify square root of 2x plus 3 minus 2 times square root of x squared plus 3x. Notice that x squared plus 3x factors as x times x plus 3. The inside now looks like a minus 2 root, ab with it equals x plus 3, and b equals x. That matches the pattern root a minus root b. In this lesson, we will simplify 2 nested radical expressions using an intuitive identity. First, we will display the word example, and right below it, the problem in bold orange math. The first expression is the square root of 3 plus the square root of 4 minus 2 times root 3, then minus 1/2 times root 6. The second expression is the square root of 7 plus 4 times root 3. To handle nested radicals like square root of a plus or minus square root of b, we use this identity. The square root of a plus the square root of b equals the square roots of 1/2 times the sum of plus c, plus 1/2 times the difference of minus c, where c equals the square root of a squared minus b. For the minus case, the second square root is subtracted. We start with the inner radical. For minus 2 root 3 is the same as 4 minus root 12. Here a equals 4, and b equals 12. Compute c. Square root of a squared minus b equals square root of 16 minus 12, which is 2. Applying the minus identity gives the square root of 3 minus 1. Substitute this result back into the outer expression. The expression becomes the square root of 3 plus the quantity root 3 minus 1 minus 1/2 root 6. Inside the square root, 3 plus root 3 minus 1 simplifies to 2 plus root 3. Now simplify square root of 2 plus root 3 using the plus identity. Here a equals 2 and b equals 3, so c equals the square root of 4 minus 3, which is 1. Therefore the square root of 2 plus root 3 equals root 6 over 2 plus root 2 over 2. Substitute and combine to get the final value for part A. For the second expression, look for a perfect square pattern. If we square the quantity 2 plus root 3, we get 4 plus 3 plus 2 times root 6, which simplifies to 7 plus 4 root 3. Therefore, the square root of 7 plus 4 root 3 equals 2 plus root 3. We start with the fourth root of 7 plus 4 times the square root of 3. The trick is to look for a perfect square inside the fourth root. Write 7 as 4 plus 3. So the sum reads 4 plus 3 plus 4 times the square root of 3. That is exactly the expansion of the quantity 2 plus the square root of 3, all squared. Taking the fourth root of a square leaves a regular square root. Now, we unnest the radical. Set the square root of 2 plus square root 3 equal to the sum square root m plus square root n. Squaring both sides gives a system. M plus n equals 2, and 2 times the square root of m north equals the square root of 3. So mn equals 3/4. Solving, m is 3/2 and n is 1/2. That means our radical equals the square root of 3/2 plus the square root of 1/2. Finally, rationalize denominators to get square root 6 over 2 plus square root 2 over 2. Example 2. Consider the fourth root of 13 minus 2 times the square root of 3 plus 6 times the square root of 4 minus 2 times the square root of 3. We first simplify the inner square root. Note that 2 times the square root of 3 equals the square root of 12. So we rewrite the inner radical as the square root of 4 minus the square root of 12. We look for numbers a and b with a plus b equals 4, and ab equals 3, which gives it equals 3, and b equals 1. Therefore, the inner radical equals the square root of 3 minus 1. Substitute that result back into the big expression. 13 minus 2 times the square root of 3 plus 6 times parenthesis square root 3 minus 1 close parenthesis simplifies to 7 plus 4 times the square root of 3. That is exactly the same quantity we simplified in example 1. Therefore, the whole expression reduces to the square root of 2 plus square root 3, which equals square root 6 over 2 plus square root 2 over 2. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.